right, so exponential functions, once again, is just something that is continuously growing at a very fast rate. So if you ever are in English class and you're like wanting to use a really nice word for saying growing fast, is you just say exponentially growing. Okay, so if you're ever saying like, oh, we just continuously get taller and taller and taller. I mean, you're not going to continuously grow. That'd be crazy. This is going to be applicable. Yeah, everything from this point forward is going to be Math 098 related, yes. But we are, like I said, going to be having a Math 098 unit. So if you struggled the past 2 chapters, you're going to basically get retaught a little bit more of it just to make sure that you understood it as you continue to go into your senior year. Okay? Math 098, I know that I just keep saying it over and over again. I know that half of you probably aren't even taking it next year. Fine. That's okay. You don't have to listen to me when I say it then. You just do you and do what you need to do. If you're going to be going into training or whatever you're doing, fine. But if you're going to JJC, you're going to have to make sure you can pass that test. Now, an example, I was just talking to Miss Case, which she's a science teacher, not a math teacher. She had to take Math 098 in JJC, and she had to pay about $1,500 for it when you're supposed to just take it in high school. Why waste your money? Just learn now. You're here anyways, right? Okay, so if that's your plan, like I said, then please make sure you're really focusing. These past 2 chapters were a test to see how you'll do. Okay, so when you get your test back, which hopefully will be by Monday, it should be by Monday for sure, not by tomorrow. I don't have enough time. But by Monday, you'll get them back, and I'm going to grade them how they're going to grade them next year. Okay, and that is basically like, yeah, I'll give you some partial points, but not a lot. So then you can actually say, how would I do next year? This is how you'll do. Okay, so it's kind of a testing how you're going to do, and then also I know what I need to help you with in that Math 098 unit. Okay, Math 098, radicals and factoring, 2 biggest things that you need to know coming from this class. Okay, anyways, Ted and Bill each earn money doing chores for their neighbor. However, they have different payment proposals. So what I like about this chapter is a lot of it that we do is actually relatable to the real world. So you actually make some kind of connection. We use exponential functions a lot in a lot of our statistics and things that we do when we talk about population. How are we going to predict what population we're going to have in the year blah, blah, blah. Okay, so for example, when we were thinking about opening another Lockport school, I'm sure that they were looking at some models that were like, okay, how are we going to be growing? This is what we're going to be getting into. I think day 5 or 6, we'll be talking about things like that with population. So identify which plan is better. Make a table for each graph. So Bill says that we're going to start with $1. So if I start with $1, that's going to be obviously at week 0. I'm starting with $1. Ted says that I'm going to be starting with $1 as well. So they're both starting at $1. Then Bill says that we're going to start for 50% more each week. So every week I'm going to gain 50% more than what I started with. Yeah, so think about money. If I start with $1, let's have $1. So now what do I have? So $1.50 is how much he's going to make in week 1. Good question on that. Okay, now again, we're continuously growing. What's 1/2 of $1.50? 75 cents. If you didn't know that, you should do 150 divided by 2 in your calculator. $1.50 plus 75 cents? $2.25. Very good. Okay, so what you're doing is you're taking half of each week and adding it to the previous week. Okay, what is half of $2.25? Well, put in your calculator. What's 2.25 divided by 2? 1.125. Okay, so let's just do one. So I'm going to put on the side here 1.13, right? Just 5 around. So now add $2.25 to $1.13. We're scoring right now. You would not have to do this in your head, but we're at 238. See if you can fill in the rest of the table. See if you can take half of each one and add it to the previous. You might need a calculator for that because so now we're starting to get into not so pretty fives like we were in the past. Okay, so in 3 weeks, he's only made $3.38. See if you can take half of it and then add it, et cetera, finish the table. So you're taking half of what you made first, and and then adding it to the previous amount that you made. When you're done, only look up and see if you got the right answer. Okay, and obviously we're going to learn about what exponential functions are, and I'll give you we'll actually be able to plug it into your calculator. But right now we're kind of just seeing how exponential functions work. Because here we're continuously growing at a rate of 50%. Okay, when you're continuously growing at a rate of 50%, this is kind of what it's going to start representing. So check your answers and let's start plotting it. So we're just going to plot bills first. We're at we're 0 weeks and we made $1. Then I'm at 1 week and I made $1.50, which is like, what'd you get? That's fine. You could have used, if you're a little off than me, that's fine. That's going to happen. So if you got 2, fine. That's fine, yeah. 5.4, yeah. Okay, so then I have 2 weeks, I'm at $2.25, which is somewhere around there. Then I have 3 weeks, and I'm at like $3.38. And then I'm at week 5, and I'm at like somewhere around $7.61 is somewhere there. Again, so I'm looking for perfect here, but $11 is about right there. So I'm just going to draw this out. Connect the dots, and boom. That is what an exponential function looks like. Exponential, as you can see, is it's growing really fast. It like starts slow and then shoots up. That's what exponential means. It starts off slow and then just shoots up and you start growing very, very, very fast. Now let's talk about Ted's plan. He started with $1 and added $1 every time. Okay, so what's 1 plus 1? 2, and then I made what? Just adding $1 every time. 4, and then 5, and then 6, and then 7. All we did is we added $1 each time. That's all we did. So we added $1. That was his plan. So that's kind of interesting. We'll see kind of what that looks like. Let's plot that. We're both starting at $1, so that blue dot is going to be Ted. Then I have 1, 2, so he's making more money right now. And then 2, 3, he's also making more money. 3 weeks is he's making 4. He's going to keep making more and more money. So 4, 5 is about here. 5, 6. In week 6, he made $7. So it looks like this. It's a line. Now, it's interesting. He started off making more money, but after about week what did he start making less money than Bill did? So week 6, yes, he still made less money, but week 4 is when he started making a little less. I mean, he's only made 7 cents less. So we're starting at 1 because it says that we started at $1. So week 0, at like right when you got, he's like, I'm hiring you, here's $1. Just for hiring you, I'm giving you $1. Then next week you make $1 more and $1 more, etc. Okay, so I'm actually going to label this. This is Ted, and this guy is Bill. And it's Ted, and that's Bill. So, and in your situation, if you want to go to your boss or whoever you do chores for your neighbor, maybe you want to give them the same proposal. I mean, yeah, it might take you 4 or 5 weeks to get there, but eventually you're going to be making a lot of money because look at how fast it grows. Okay, so now let's talk about these actual functions here. So I gave you Bill's function right here. You're not going to have it created ever, but that's his function. It's called an exponential function. What does it mean to be an exponential function? I'm going to circle this, maybe star it, box it. This is what it means to be exponential. You have an x or a variable in the exponent. Exponential exponent. Okay, so that's why it's an exponential function. Whereas Ted function is going to be a line. So this is going to be linear. Now, way back when, I know you did this freshman year, we had this formula called y equals mx plus b. That was your slope, right? Okay, so the reason why we're using this function is because we're talking about a linear function. He's got a straight line. What's his slope? See if you remember from way back. Remember, it was rise over run. How many did he go up? He went up 1, and how many did he go over? Careful. Careful, look. Up 1 over 1. It looks weird because look, there's 2 dashes. I get that. But they went by 0.5s here. They went 1, 1.5, 2. So I went from 1 to 2 here. So I only moved over 1 time. Okay, so I went up 1 completely here, and I moved over 1. So my slope is just 1. So you see how they're going up by 0.5? So this is 1.5. This is 2.5. So like when you go over 2 slots, you're going by 0.5, technically, 50 cents. So I have, my slope is going to be 1, so I'm just going to put 1x or just x is fine. And then your b, does anyone remember what your b value was? This was, yeah, I heard it, someone. It's your y-intercept. What was our y-intercept? Where is it across the y? At what number? Or where did we start? How much money? Well, we started 0 weeks, but how much did we make? We made $1. So again, I'm not going to ask you to recall this information on an exam right now, but I'm just showing you the difference between the two. So that's his function. Now that we have their functions, we can plug it into the calculator. So you will need a calculator because this is very hard to do without one. We're doing exponential stuff. It says how much money will Bill make in the 20th week? So all we're doing is we're plugging it in. So B of 20 is equal to $1.50. I'm going to just drop the 0. Only, I mean, you can keep it in there, but it's just unnecessary in terms of plugging into the calculator. And 1 point. We did not do exponential yet. However, right here is what we're going to do, is we're going to plug in the 20 where x is, and everything else stays the same. So in your calculator, let's plug that in. You need to get practice putting this in. 1.5, parentheses, 1.5 again, close it up. Not square root. Here, hold on, I will do it with you. Let me get my calculator out. Yep. Or you can just know that 20 minus 1 is 19. No, we're just going to plug it in. I'm going to show you once my calculator, it is a decimal. Well, yeah, we're talking about money, right? What? That's not, it's not 2.25. I'll show you right now. Here we go. My calculator is slowly pulling up here. I want you guys to get used to your calculator. So I'm going to go back to the beginning. All right, here we go. We got 1.5. Then you have your parentheses. 1.5 again. Now here's where a lot of people get it wrong because they don't know how to put this in. If you don't have a fancy calculator, it's not going to bring everything up with it. So you have to press this caret symbol, which is here in red. And if you don't have a fancy calculator, there's 2 things you can do. You know what 20 minus 1 is. You can put 19. Okay? Or you'd have to put it in parentheses. So I had to do 20 minus 1. Because everything's being raised to the power. And I'm going to press that enter button, and I get $3,325. So after 20 weeks, for working 1 week, he made $3,000. More than that. Okay, so for working just 1 week of work, he made $3,000. Yes. Sign out and grab that. All right, so let's put that in. My calculator or my computer might die. We'll find out. Okay, so I got $3,325, and we're talking about money, so raise it to the obviously, to look like money. If you put another decimal, it's not money anymore. I'm gonna have to stay right here because I'm going to, not me personally. Well, that's it. Actually, let's take this. The questions on that part. There's a reason why you're making that. Every week you're getting half of what you previously made. That's a lot of money. Well, because you need to plug in, you need to put X in there. All right, so how much will Ted make in the 20th week? So we're just going to do the same thing. Now let's plug in 20 one more time, but now into Ted's. So I have 20 plus what? Oop, I forgot to use this. All right. I have 20 plus that 1. Because again, that's what the function is right here. So compare yourself here. I'm Ted. In 20 weeks, I'm only making $21 a week, but here I am, Bill. I made $3,000. So you can see the difference between an exponential graph, or exponentially making something, or exponentially growing, versus just a linear, something that's just a straight line. Okay, obviously you'd want to choose Bill because it's a lot of money. I don't make that much money in a week. That's insane. Okay, and then if you do it again, it's going to be a lot of money. So the job of the exponent is repeated multiplication. Every single time that you have an exponent, it's going to be repeated multiplication. So I'm going to put repeated multiplication. Again, because 3 squared is 3 times 3. 3 to the 5th power is 3 times 3 times 3 times 3 times 3. You're repeating it over and over and over again. So what I mean by that, I'll put a little example for you, is that 3 to the 5th, like I told you, is going to be 3 times 3 times 3 times 3 times 3. Okay, as you can see, it's going to grow really fast because you're going to be multiplying by 3 5 times. And we know that. We've talked about that. What happens when you have a negative exponent? We talked about this last 2 chapters ago. It doesn't cancel. If I have a negative exponent, so for example, if I have 3 to the negative 5th, opposite, what were you going to say, Edward? Opposite, which is to flip it. So a negative exponent, that's extremely important in this chapter. When you have a negative exponent, it changes its position. It's currently in the numerator, technically, because it's over 1. It needs to be flipped. So I have 1 over 3 to the 5th. Whenever you have a negative exponent, it now takes that position and moves it to the opposite. Move it to the denominator. Okay? And flip when you're ready to move on. Okay, problem 2. In this chapter, you will be introduced to 2 new functions. We have an exponential function first. We'll talk about logs, which is like way in the future here. Next week. Exponential functions are the form of this. So we have this letter A. It means something, and this B is our base. So we have our A value is any real number except 0. It's going to represent that initial amount. So like I'm starting with $5 every week. I'm starting with $5. That would be like your repeated multiplication. Yeah. That 5 times 5 times 5 times 5. What'd you say? So what are you talking about? What? So A is any real number except for 0. Yeah, it could be negative or positive. It just can't be 0. Good question. So what we're talking about right now, this is your A value in green. And your base, it's called your base. That's their purple one here. Okay, that's your base. Okay, we'll go over it. I was just going to write that out for you. So the A is any real number but 0. There's a reason, because if you plug in 0, 0 times anything is 0, then you're not actually growing, you're just 0. That's why we can't have 0. So A is going to be your initial amount, which is what you're starting with. Bill started with $1, and then we went up. Okay, and then here it says B represents any positive number because it's going to be the rate of growth or decay. How many of you have taken physical science in this class? Decay. Yep. Okay, so decaying means it's like, yep, it's going down, it's decreasing, yes. Okay, so the B value is going to tell you if we're going up or if we're going to be decaying, going down. In physical science, you learned about growth and decay when you guys were doing like your half-life. Okay, back when? Okay, growth and decay, again, very, very important in terms of like everyday real life, and we'll get more into everyday real life in the future here. So, which of the following functions are exponential functions for any function that's not, state why. Okay, Exponential function just tells you that you have an x in the exponent. Do I have an x in the exponent? Yeah, that's an exponent. Yes. And I'm going to like maybe circle or star that's why. This piece right here is why I have it. Does this have an x in the exponent? No. This is linear. Okay, the x is not in the exponent, it's in the bottom. What about letter C? You're right, it is no. Look. See how there is an exponent? What is it? 3, it's not a variable. In order to be an exponential function, the variable must be in the exponent. It has to be, it could be y, it could be z, it can't be a number. It could be 2z, but it has to have the variable up there. So here for D, look, do we have an exponent variable? Yes. Oops. Yes. And again, I'll point to y is this right there. What about E? Yes. This piece. And F. Yes. Okay, pretty straightforward. That exponent variable is what makes it a function here. Now let's talk about what the A and B values are. I'll just do like these last two here. What is the A value, or what's your initial amount in this problem? It's 5. Very good. I'm going to highlight it. Your A value is always the number all the way out in front next to the equal sign. So in this function, let's just say like you were going to be making money in this situation. You'd be starting, like when I hire you, you start with $5. Is what that means. Okay, so that means that in the very beginning of whatever this is, if you're making money, you'd be starting with $5 in this situation. Okay, in this one, how much would I be starting with? 1/2 in terms of money would be 50 cents. Or you can put 1/2 so it doesn't confuse you. Now let's talk about what B is, which B is your base. Think B base, B base. B is the base of where the variable is. Yeah, so E here is going to be that -2/3, and you can just leave it as -2/3. Ooh, wrong one, guys. I'm so sorry. I've been really off today. It's 20%, but we're going to use the decimal. Okay, so the base is the base of the exponent. The exponent is attached to it, is what that means. Okay? Now, find each indicated value. Write your answers in, we're just going to write it as to begin. So let's plug it in. We have this function right here. I'm going to circle it just so you know this is what I'm referring to every time. Let's use our rules of exponents, which is going to be super important for 09A is the rules of exponents. Rules of exponents, you have to start mastering pretty good here. Let's plug it in. So I have 3 times 4, and all I'm doing in green is plugging in -3. Now, you can obviously put that in your calculator and solve it. However, I want you guys to understand what we're doing and what this means. Do you remember what I said about what happens with a negative exponent? What happens? Yeah, it flips. So I'm going to go ahead and rewrite this as 3 times, now it's flipping, I'll change the color, 1/4 thirds. Does someone tell me what 4 cubed is? Does anyone know off their head? It is 64. That's awesome. Okay, so really you have 3 times 1/64, and I'm just going to cross off B so we can keep writing. Okay, so technically I have 3 times 1/64, which is equal to 3/64. You could have 100% plugged in your calculator. We're not going to take your calculator away. It's good to know that the negative, in my head, is the most important part, is for you to know that the negative makes it go to the denominator here. Yeah, we're not going to do the decimal form. Don't worry about that. Because 3 is technically, whenever you have a whole number, it's technically over 1. And when you multiply straight across, you get 3 times 1 is 3, and then 1 times 64. Good question. Okay. All right, let's do C because it's actually very fun and interesting. When I plug it in, here we go. 3 times 4 to the 0 power. What is anything to the 0 power? It's not 0. It's 1. Good. Okay, it's a weird exponential rule. We talked about it last time. Right now, if you put your calculator for the 0 power, you're going to see that they give you 1. Okay? So 4 to the 0 power is going to give me 1. Hey, so then that gets me 3. We're not going to make a fuss if someone walks in the door. 3 times 1, which is 3, is my final answer. So knowing that to the 0 power and then 3 is the number 1, I have 3 times 1, which then gets me 3. Okay? Questions on that part? All right. The rest of them, I wanted to make sure that you just explored it a little bit. I want you just use your calculator. Okay, so you could just hear 3 times 4 to the negative 6. Let's plug that in your calculator and see what you get. You're going to get a fraction or a decimal. Either one's fine. So you have 3 times. Be careful, I think. Yeah, you can cross off that. Question? What did you say? So I get what you mean, why you think it might be 12, but it's not turning into, for the 1 power, the whole thing turns into 1. So 4 to the 0 is equal to 1. 5 to the 0 is 1. 8 to the 0 is 1. 100 to the 0 is 1. So when you simplify for the 0, you just get 1. You don't get 4. Okay. If you're going to do that way, it's to the 1 over 4 to the 6th power. The negative drops when you switch. So if you want to do it in your head, it would be 1 over 4 to the 6th power. So the moment you switch it, the negative drops. But I'm going to show you in the calculator how you would type this in. So I would have, here we go, 3 times, and I'm going to keep it as we originally plugged it in, 4 caret, the little caret symbol. Make sure you're using the negative and not the minus sign. So negative 6, and you're going to get this answer. Oh, you did get 7. Thank you. I'm sorry for totally disregarding what you said. Now, when you press math, enter is a cool little trick. You're going to get your decimal, or you're going to get your fraction. How cool is that? Do it again. Press math, the math button, which is in red right now, and then press the enter button and enter one more time. Only because I don't know why your calculators have been like reset where you can't do it. Don't worry about it. I'll accept the decimal form, but I'll put it in the notes, the fraction. Okay, so you would just plug that in. To the e to something, it moves over. Yeah, I got it. That was a weird one. Let's just do one more with this fraction. I'm going to cross off h. Let's do 3 times 4 to the 1/3 power. Anyone know what 1/3 really means, what we talked about in the past? Oh, I'm sorry. Yeah, that's what, yep. So the denominator, remember, totally get it. So kind of remember here, when you have an exponent with a fraction, that's really like a radical, which is what we learned last chapter. Okay, really technically, that 1/3 means the cube root. If I put 1/2, that's the square root. If I put 1/4, that's the fourth root. That's what that means. Well, let's put it in our calculator because you will be able to use a calculator. I'm not going to take your calculator away from you. Let's put that in. So 3 times 4. Use a little caret symbol. And that caret symbol, some of your calculators are not as nice and friendly. You want to use parentheses whenever you're working with fractions. So I'm working with a fraction here, so I'm going to do 1 divided by 3 and close it up, and I get the answer of 4.76, and that's fine. I'll accept that. Equals 4.76. Okay, so just kind of recapping what we did. We're just exploring today. This is not like, I'm not really going to test you on what we just did. I wanted to give you an introduction to what exponential functions are and how we work with them. And tomorrow we'll get into more depth with like how we use them. Okay, so is there any number that you are not allowed to substitute into a function? And that is no, you can plug in any number into the world and get that answer. That means that your domain's not restricted. You can plug in any value and get your answer. Is there any number that would not be a value of a function when all possible numbers are substituted in for x? Okay, so think about this. It is zero. Why did you say zero? Yep, exactly. What about anything else? You can use one. I mean, negative numbers. Very good. Negatives. Okay, so again, any number that would not be a value of the function when all possible numbers are substituted into x, you're not going to be negative. You're not going to make negative money. You can't go to work and be like, oh, you worked today, give me $10. Like, I'm not going to do that to you, or no one should do that to you. If they do, they're robbing you. That's what's going on here. So we're not going to have negatives when we're growing exponentially or decaying unless we transform it up or down, which will be here soon shortly. So based on your answers above, what is the domain and range? That means that we're always going to be able to put in any number in the world. But our range, that's our domain, and our range is going to be from 0 to infinity. Because you told me that we can't have negative numbers. If I give you a number 5, you're not going to make less money than you started with. So that's why we are not including the negatives. So really,